In this snippet, we will discuss chapter 7 of this book. It has an unusual title, Batteries Are a Treacherous World. But there's one of the reasons why I like this book is, besides making the battery research interesting with variety of anecdotes, it also brings in certain other complexities, wherein commercially consequential research is involved. So let's move on. So there is a good quote in this book that is important for every student, every researcher. Okay, so he says that um, things, it talks about things that matter in research involving lithium ion batteries, but I think it's in general applicable to uh, any form of material and chemical research in, let's say, material science, chemistry, chemical engineering. So he says that Goodenough's lab, and Goodenough in particular, brought these three things together: an intuition, okay, or a conceptual understanding of materials that usually comes from, let's say, solid state physics, um, combined with meticulousness of chemistry. You have to do many detailed, systematic uh, reactions and experiments that are often a feature of chemistry, and recognize some patterns. And finally, the problem, chosen problem, is important. Okay, so that's where engineering background or engineering outlook is important. Okay, it brings in certain pragmatism, certain um, practical aspects of what problem is important. There are infinite number of questions and problems, and what questions, which when answered is consequential, that is a feature that is reflected in engineering. So to be a good researcher, all three things are quite important. So in a way, Edison was one of the first person, um, and his lab brought out this feature to um, great effectiveness. Okay, so Edison, in the beginning, he did all these things by himself. He had a fairly good understanding of um, uh, physics, okay, and electrical engineering and so on. And he did a large number of experiments. Okay, so in fact, when you contrast um, Tesla and Edison, they were contemporaries and competitors. One thing that differentiated Edison from Tesla is that Edison's approach, what is often called Edisonian approach, is to do large number of experiments with some idea. Okay, so it's not just blind experiments. So he Edison had some ideas, and he explored lot many materials till it became commercially consequential. Okay, so at least that was an approach. Um, it was first practiced by Edison, and to implement this at a large scale, he brought out a lab, okay, a private lab at that time. So consistency and vision is also important. Okay, so in this um, chapter, or in this book itself, this is clearly visible. Okay, so there are some people who had certain lead. Okay, for example, Whittingham worked in Exxon Mobil lab. Exxon lab, Exxon company was a company that is that emphasized oil. Okay, so oil, especially in the context of energy, and probably in the context of chemicals too, petrochemicals and so on. Um, so the initial breakthrough for one class of cathodes was made by Whittingham in Exxon. But as soon as the energy crisis fizzled out, they gave up that research. Even though they had an initial lead, they sold the patents to some other places. So Whittingham moved on to universities. Even universities which depend upon funding from government agencies um, do not have a long-term consistency and vision to get some products in to market. Okay, so that is often done via individuals who eventually have to have a vision and consistency to work over 30 years or so. Okay, so many questions are often answered over many PhDs in a particular lab. Okay, so just a 5 year period, which is, let's say, typical of a PhD research, can give you certain clarity on certain questions. But many PhDs have to be built on top of each other over a period of many decades to get um, consequential, revolutionary technologies. So that is clearly visible here because Goodenough's quest span over uh, many decades. Okay, so even till his death in last year, like in 2023, he was working on breakthroughs in battery technologies. So market needs might vary in the short term, okay, depending upon, let's say, an energy crisis because of a particular war, uh, and it may fizzle out. Okay, so despite that, you need to have a long-term vision to get things uh, from fundamental research all the way to the market. So Edisonian approach has been practiced extensively in Japanese. Okay, so by especially in Japanese industrial R&D conglomerate, this has been mastered. So many a times, some inventions which were nucleated in America went on to be perfected by Japanese. Of late, Chinese have also done this, Koreans have done this, but Europeans have not profited much from this approach. What do I mean by this approach? Bringing these three things together. Okay, have ideation comes from some concepts, but extensive optimization is required on a problem of consequence. So all these things are important, and this book brings out these things in a case study manner in on a topic which is very important, right? The electric vehicles is sort of considered to be very important for renewable energy transition. So this book makes these things quite interesting and so on. So all three classes of cathodes that have gone into lithium ion battery have had its contentions, have been disputed by many players in this um, field. For example, one class of cathodes that are very important are LCO. This was originally perfect, invented in Goodenough's lab in University of Oxford, and Oxford University didn't think it will have commercial consequence, so it really didn't want to patent this material, which seems like a blunder in hindsight. Okay, um, that is one class of materials that are important. Um, then another class of compounds are spinel compounds. Okay, so this was originally was a product of a collaboration between Thackeray in Goodenough's lab. This was went on to be a precursor for NMC research later at Argonne by Thackeray. Thackeray was sponsored by South African agencies. They were keen to patent, but again, University of Oxford was not too keen to patent. Again, another class of material which in which Goodenough contributed was olivine kind of class of materials, which gave rise to lithium ion phosphate. Okay, so if in the earlier chapters, as you may remember, that the Chinese companies, electric vehicle companies, have focused on this because iron is inexpensive, phosphorus readily available, and so on. Okay, so these these two materials have an advantage over this class of material because cobalt is very expensive and hard to mine, and it has its own complexities. So sustainability of materials is very important. Um, this chapter brings out how a Japanese scientist working with Akshay Padi. He was a researcher in Goodenough's lab. Um, Once he leaves Goodenough's lab, the Japanese researcher goes on to patent it with Nikon a particular Japanese company. Okay, so there is a lot of patent intellectual protection drama that is brought about in this chapter. So it's important to understand that these are all extremely important. Notebook is a technical document that is often evaluated when it comes to patent legal fights. Okay, so so ironically, John Goodenough was involved in all these three um, class of materials which have been commercialized elsewhere, and he hardly got profits from the commercialization of these materials. Okay, so LCO was commercialized and a company profited extensively from portable electronics. When lithium ion batteries is used in portable electronics, Goodenough really didn't benefit from that. As I said, this South African agency that sponsored Thackeray to Goodenough's lab um, uh, filed the patent for this class of material. And this is a different story. Yetming Chang's group in MIT optimized these kind of materials, and there was a very contentious battle between MIT patent lawyers and the patent lawyers of University of Texas at Austin, from where Goodenough did this work. Eventually, the MIT legal team won the battle, and all these interviews from different players are elaborated in this chapter of this book. So you should go through this book just for these reasons. It not only talks about a lot of science, engineering, technology, but other complexities that are important in modern day research. So in the next chapter, we will elaborate more on the elements that went into creating the advanced cathode containing nickel, manganese of cobalt. That will be the topic of the next snippet. Thank you.